All right, so this is number 3 from.
What's your number?
16. All right, so this is number 3 from Tuesday's assignment. We want to approximate. This right here is a big word. Okay, it should draw our attention every time we see that word. So we will approximate average temperature in degrees Celsius of the water over the time interval from 0 to 15 using a trapezoidal approximation, subintervals of 3 days. Okay, so 0 to 15, so there to there, there to there, there to there, there to there, and there to there. So there are my subintervals.
What is your, so it's like, so you use the area of the trapezoid, right? It's like 1/2 B1 plus B2 times height, right?
Yes.
So would 3 be your height?
3 is my height.
And you do 20 plus 71?
Times a half. All right, but let's get back to this average piece because we need to get that average piece taken care of. When I see that word average, what do I need?
A-rock.
I need A-rock. Okay. With what values? If I want average temperature, what values do I need? What? I want what time on the bottom? Alright, I want to integrate W. Alright, so what I'm wanting you to understand is anytime I want to do average of something, I need the change in the function above the function I want the average of. Because when I wanted average acceleration, what function did we use to find average acceleration? Velocity. When I wanted average velocity, what function did I use? Position. That's something we need to understand. If I want average of something, I need the function above. Okay, so if I want average temperature, then that means I need to go to the function above temperature. And how do I get to the function above temperature? I integrate. So I want to integrate W of T dt, and I want to integrate from, it says 0 to 15, and since it's average, I have to divide by 15 minus 0. Okay, that's the first thing I want to make sure we understand is setting up the average part. Now, it wants me to approximate this with the trapezoid. Okay? Now, what I like to start doing is anytime I'm doing a trapezoid, I'm going to take that 1/2 and I'm going to stick it out front. Okay? And then I'm not going to worry about the 1/2 the rest of the way. Then all I need is the height and then my bases added together. And then I move on. So as Zach said, the height on the first one is 3, and then I add my bases together and I get 51. Okay? And it looks like my height is always going to be 3, correct? So that means I could just stick that 3 out here and then just add the bases together. So the next two would be 31 and 28, which would be 59. The next two, 28 and 24, which is 52. The next two, 24 and 22, 46. And the last two, 43. Okay? Somebody have that for me?
376.5.
376. Did you put this out here?
Yeah.
You already did it? All right. Good. Now, what a lot of people do is a lot of people circle this as the answer. Because what do they forget to do? Plug it back in. Now, what's something I can do to avoid forgetting to divide by 15?
Look at it and see if that makes sense.
All right, there's what I'm looking for, what John Ryan said. Always check to make sure your answer makes sense. So right now we're saying 376.5 degrees Celsius. And I want an average temperature. Here are all of my temperatures. Does it make sense that my average temperature could be 376.5? No. So that means I forgot to do something. I divide by 15, what do we get? 25.1 degrees Celsius. Then I come back up here. With all of these, does it make sense that my average could be 25.1? Yes. There it is.
So, say we do like say you have like a negative, like you decrease when you do like so you do say you do like a right, how do you say it?
Riemann
sum. And so say you go from 60 to 30 on your value, so that means you're decreasing. So would you put minus 30 instead of
if you're doing trapezoid, you're adding them together.
No, I'm saying like for different, like right, when you're not doing trapezoid.
There's a problem on here we'll look at that answers your question. As long as it's not a trapezoid as well, because one of these has negative values in it. No, it's the very last one. It's a trapezoid though.
What about number 1?
Yeah, but there's no negative values. It doesn't matter if it decreases.
So even if it decreases, you don't put a negative on it?
No. Whatever that number is, that's what I'm taking. If that number is negative, then I'm taking a negative. If that number is positive, I'm taking a positive.
Okay, so you'd be like 0 to, since it's asking for right, 0 to 5, so it'd be like 5 times 12.
Other questions on this worksheet from Tuesday, Alidi?
Okay. On number 4, where it says, is the numerical approximation less than the value? Do you just like get the value and see if it's, I don't know.
All right. Can anybody feel good about answering Alidi's question? Everybody hear her question? She wanted to know, how do we figure out whether or not this is less than or greater than? Ethan, what do you got?
Is it an over approximation because the rectangles are higher than the graph?
All right, there we go. That's pretty much what you're doing. If you visualize drawing your rectangles, I have that. I have that. So all of my rectangles are more than the actual graph. So it's going to be an overestimate. Okay, so in this case, the answer would be no. Now, somebody give me a better, what he said is perfect, but they're going to want a different reason. Ivan, what's my different reason?
So, would you like say like the concavity is positive and the reading sum is right?
All right, I'm glad you're thinking back to concavity, because concavity would tell me when I'm dealing with the tangent lines whether or not I had an over or an under. Okay? But if we're dealing with this, we're dealing with Riemann sums, concavity is not going to get the job done for me. Anybody else have an idea? What's this function doing? It's increasing. Okay, so what you would say is no, because R is increasing and a right Riemann sum was used. Okay, that's what you would say. Okay, if it's decreasing, if my graph was decreasing and I used a right Riemann sum, what would happen? It'd be an under, because all of my rectangles would be under. So when they want this justification right here, they want you to pull in the fact whether or not it's increasing or decreasing, and whether or not you're using a right or a left. That's what they want you to write down.
If it was decreasing, how would the last one be under the line?
Say that again.
If your line was decreasing, how would the last triangle, how would that be an underestimation?
Rectangle?
Yeah, how the last rectangle over by 90.
Right.
And say your line was going down, how would that?
So if I take this and switch everything, let's switch everything. So we're here, and then we're over 3, and then we're here, and then that one's going to be about the same because that's in the middle, and then this one's going to be here, and then that one's going to be there. So that's what it would look like if it was decreasing. So if I drew every one of my rectangles, that's under, that's under, that's under, that's under.
So did you split the order?
Well, if it's decreasing, I have to. I can't be decreasing and my numbers get bigger. Okay, so that's how, what they want to know, is it over or under, or using Riemanns? They want to know increasing or decreasing, right or left. That's what they want to know. Good question. What else? Anything else on this one? Abby?
Number 7. Wait, no, number 8.
All right, number 8. Average acceleration of train A over the interval from 2 to 8. So again, right here, there's that word again. And I want average acceleration, so that means I need to change in the function above, which is velocity. So I need to change in velocity. Did they give me velocity? Yes. So all I need to know is what's my change in velocity from here to here, and then divide by it. Make sense? So if I plug in 8, I'm going to get negative 120, minus, if I plug in 2, I'm going to get 100, and then over 8 minus 2. Now let me pause and make sure everybody's buying what I'm selling. Everybody buying that?
So what if it wouldn't have given you velocity?
So what if it wouldn't have given me velocity? What would I have to have done?
Well, you have to find error and then find its way. Like
Instead of this up here on the top, what would I have to have put here? I'd have to integrate. So I'd have to integrate acceleration, and then they'd have to give me acceleration values there to use a Riemann sum to get my answer.
basically with this, if they ask you for, I don't know how I'm trying to word it. If they give you acceleration right there, could you still? I don't know how I'm trying to word it. How I want to word this. Never mind. I don't know what I'm trying to say.
Okay, so when they do average, they're either going to give you the values, or you're going to have to integrate to get the values. Make sense? Everybody with me? So what does this end up being? Anybody do it? Yeah, it's negative.
110
Negative 110 over 3. Give me a decimal. 0.6. Okay, and my units would be meters per minute
So
squared.
wait, what if they were giving you only acceleration in that graph?
Then I would have to write an integral here and then use a Riemann sum to get my answer.
But it didn't tell you what time Riemann sum you want. And
Right, they would have to tell me that.
so with this information, if it had acceleration in there, and you only change that problem with acceleration, and
They would have to tell me what it is,
so you
which
couldn't
one they
find
want.
it with the given information right now.
Right, they'd have to tell me which one they want. All right, does it make sense? Is this feasible? Yes, it's feasible because we're here and then we're pretty small. So negative 36 is somewhere in that mix. All right, now on this one, we want to integrate this using a trapezoid sum. So I'm going to stick 1/2 out front. Okay, we're going from 2 to 12. Am I increasing by the same amount each time? No, so that means I can't pull my next value out. So that means each one of them is going to be, yeah, but what's the word? I was looking for a fancy word. Unique. There we go. So I've got 3, and then I add them together, I get 140. The next 2 is also 3. Add those 2 together, I get negative 80. The next 2 is 4. Add those together, I get negative 270. Anybody have this value for me? Negative 450. Units? Okay, somebody else raise your hand and tell me how we get meters. There's 2 different ways we can get meters. Mallory?
Because the minutes cancel.
Why do they cancel? You gotta tell me one of 2 ways that they cancel.
Because like you multiply together. It's like one over the other one. Because then like,
Alright,
I don't know.
I want a little bit more exact.
I don't know.
Abby.
Finish what she's saying basically. That-
Kinda. Give me something.
Okay, well, yeah, if you were to do the, like, put them on top of each other, it would be minutes over meters per minute, which is the same thing as minutes times minutes over like you just flip it, do the reciprocal.
Alright,
and then cancel.
you guys are making it too hard. Anytime I'm integrating, multiply those together. Anytime I'm integrating, multiply those together. What happens when I multiply those together? The minutes go away. Okay. The other thing is, I'm integrating velocity. Velocity is sitting at meters per minute, and when I integrate something, what happens to my units? The time unit goes away or reduces by 1. Those are the 2 justifications I want you to be able to say when I ask you that down the road. That
I feel like you're restating what you just said, but so could you look at like anything outside of parentheses in minutes, like visualize that in your head, like the 3 to 3 to 4 or whatever value you have in your problem are the minutes.
yes, these are the minutes,
And inside is your meter.
and then those are the meters per minute. Yes, you're multiplying. So, good. Anything else on this one?
Gotta explain the meaning.
Oh, explain the meaning. Good. Raise your hand. Somebody new. Explain explain the meaning to this bad boy.
Can I try?
Somebody new. Ready? Nothing?
Just try.
Haley? Jarrell?
Does it have something to do with it? No, not that.
Roshan?
The approximation for how much distance the train traveled from 2 minutes to 12 minutes.
You're close. We need to have to be a little bit more specific than what you said.
The approximation of the area.
Well, when I use area, that's what I want to use to help me find the value, not explain the value.
Okay. Then I don't know.
Jennifer? Natalie? Carter? Edway?
The train went backwards 40 meters between 2 and 12 minutes.
Closer. I like him. He's the closest so far. But here's the problem. What's happening right in this section right here? Which way is the train going here? It's still going to the right. Okay? But what happens when we get to these negatives? What starts happening? It starts going backwards. Okay? So from this point, my train went this direction, but then it stopped and went back this direction. Okay? So what this is this is its current position. So it didn't travel minus 450 this way. Okay? It went some distance to the right and then came back to the left, and this is where we are in relationship to 0. Make sense? So the word we want to use here, write this word down. And some of you may know this word. The word is displacement. Anybody tell me what displacement is? Or apply it to this problem and kind of figure out what displacement is?
It's not in place.
John Ryan?
It kind of equates to the net distance. Like the net distance means it goes positive and then it goes negative. And you add those together.
All right. It's not total distance though, but I'm glad you brought that up because that's the confusing part about these two. Displacement is how much, where I ended from where I started. How far am I away from where I started? That's displacement. Make sense? How far am I from where I started? That's displacement. Okay? Total distance is, if I went one direction and then went the other direction, total distance is how much did I go this way and how much did I go that way and put it all together. That's total distance. Everybody with me? So displacement is how far am I away from where I started, not did I go this way and then back that way. You understand the difference between the two? Okay? So that's the main difference. Now, here's how you tell it on an integral. Okay, so in this case, I had velocity. Here's how you tell it in an integral. If you do not have absolute value, you're dealing with displacement. If you do have absolute value, you're dealing with total distance. So write that down. That's important stuff. Okay, so in this case, notice, do I have absolute value on velocity? No. So this is from where I started, I am 450 meters to the, does it say east and west or right and left? East and west. So which way, that's tough to tell you on east and west, which way is the train going to begin with.
What if it's going north or south?
Right. So if it's north and south, the north would be the positive and south would be the negative. If it's east and west, I think the east is positive and the west is negative. So this would
What
be,
if it's going towards the west from the east?
So this would be 450 meters west from.
so this is 450 meters west from where we started. That's what's going on. Okay, but this, I'm glad we brought this up because this is important stuff right here. This will come back to us later. Anything else on this one before we move to another assignment? Okay, the next assignment was the book page, if I remember correctly. Any issues on the book stuff?
Actually, kind of.
Yeah, I know.
Any issues on the book?
I
Mallory?
have a couple questions. So, like, on like the last couple ones, like 42.
What page are we on?
44.
312?
312. So,
Alright, which one?
like 42, 43, and like so on, where it like kind of gets complicated.
Yeah.
Like on 42, like when you plug it in, like that number into X, do you still like cube it and then add in that gets your answer?
No. Alright, so 42, let me write down what they give us. What was that? What was that noise? Okay, and I'm not even going to write the last one down. You probably shouldn't even use the right one. The right one doesn't even need to be there. Alright, so which one were you asking about? Which one do you want to see?
42, and then like do one of the complicated ones, like 43 or something.
2 to 4 x cubed plus 4 dx. Alright, 42. Anybody want to talk to us about how to do 42? Brady?
You like separate it?
Separate it, very good. So 2 to 4 x cubed dx plus 2 to 4 4 dx. Very good.
And then the first one is 60. And then the next one you just
Don't look at. You don't need anything up here. You should be able to look at this and tell me what it is. Anybody help her? Zach?
4.
No. Abby?
You multiply the 4 by the amount between.
Right. How far is it between here and here? 2 times 4 gives me 8. 68. Okay, that's why I don't even know why they put that third one up there. You don't even need it.
Okay, yeah.
Because you can do it without.
Say it was 4 to 4, maybe a 0.
So like on
What was the other one?
43. Like, so do you like split and like so on, like where
Yeah.
they're like super confusing? So you just split each individual one.
Work each one by itself.
Okay.
Good?
Yeah. I wasn't just sure on how to do this.
Alright, yesterday's worksheet. Alright, questions on yesterday's? Hunter? 9. Alright, 9. I got the integral of x plus 6 divided by the square root of x dx. Raise your hand if you can help me on this one. Roshan?
Alright, so this is what I did. I separated them like you did show in the video, so I have x over square root of x and 6 over square root of x. And then I thought when like you have the same variable, and so I changed square root of x to the 1/2. And when you have you're dividing, don't you just subtract powers? Okay, so then I got x to the 1/2 plus 6x minus 1/2, and then I added my 1 to the power.
Right, let me stop here and make sure everybody's good at this point, because this is the hard part of this problem. Everything else is pretty simple. Questions on how we got here?
So what? I got.
Yeah, can you
Alright, so we have, he's talking about x over the square root of x. So he's taking this, and then he's doing plus 6 over the square root of x.
So you already have 2 x's there, so how do you only get x to the 1/2?
Well, I'm getting ready to show you. So this is the same thing as x over x to the 1/2. Okay? If I have x to the 5th over x to the 3rd, what does that end up giving me? X to the 2nd. Now, how do we get x to the 2nd? We subtracted top minus bottom. Well, right now I've got a 1 here. So 1 minus 1/2 gives me x to the 1/2. Same thing over here, 6 over x to the 1/2. Here there's nothing to subtract with, so I need to move it to the top. To move it to the top, we just make it negative.
So why did you make the extra one negative on the first one?
Because the bigger exponent was on the top.
So if that, say it would have been 6x squared over the square root of x, you wouldn't have to do x. Or it would have been, never mind.
It would have been 3/2.
Okay.
Alright, so I add 1, which gives me 3/2, multiply by the reciprocal, which gives me 2/3. I add 1, which is 1/2, multiply by the reciprocal, so that'd be 2 times 6, which gives me 12, and don't forget the c. What does c stand for? Constant of integration.
Is your reciprocal not negative? Or you multiply the reciprocal of 1/2 or negative 1/2?
You always add before you do the reciprocal. Good, what else? What'd you say? 11? Alright, 11's similar to the last one we did, except on this one, instead of subtracting our exponents, what are we going to do? You're going to add your exponents. So this is y squared and y to the 1/2, so I need 2 plus 1/2. What does 2 plus 1/2 give me? 5/2. And then I add, so that gives me 7/2 multiplied by the reciprocal plus c. Abby?
Wow.
You don't like the 5/2 part?
No, I just don't really know what happened.
Okay, I've got y squared times y to the 1/2.
Okay.
So I need to add, so that's y to the 2.5. We don't want to deal with 2.5. So 2 times 2 is 4. 4 plus 1 gives me 5.
I should know you could multiply. I thought you had to like separate it like you did the first one.
No. When you're multiplying, add the exponents. When you're dividing, subtract the exponents. What else? 10. Raise your hand if you have a recommendation for me on 10, Ryan. FOIL. Multiply it out. So that's 3x squared. That's going to be 3x and negative 2x, which just gives me x minus 2 dx. And then from there, you're just integrating each one of them by itself. So the x squared turns into x cubed. I divide by the 3. The 3's cancel. Then I have 1/2 x squared minus 2x plus c.
So on the last one, you number 7 or whatever, you multiply by the reciprocal. Why don't you do that here?
I did. Well, you really only want to deal with the reciprocal if you have a fraction exponent. If you don't have a fraction exponent, then you're just dividing by whatever your
So
exponent
if you would have had x equal 3x, you would have been 3x and 1/3, you would have gotten 9x to the whatever.
Yeah. So if you got a fraction, multiply by the reciprocal. If it's not a fraction, then divide by
Put
it.
it over.
What else?
Well, test correction time.
We good? How do you guys feel about that 3 days of stuff? Feel all right?
Yesterday was
It's not. I'm not fully there yet. Like I got it. It's just a lot.
But you're getting there.
I'm just behind, so like
Were you here yesterday?
yeah, but I was kind of
You're-
just checked up from the other days, yeah. So
Have you watched this one yet?
I've watched like 5 minutes of it.
Go back and watch this.
Yeah.
This really isn't that bad.
Yeah, I like got like full like gist of it, like what you're supposed to do. I just haven't like worked out the problems to really know how to do it.